Regardless, integration can be used to find areas, volumes, central points, and many other useful things. There are many different methods to finding different types of integrals. In today's lesson, we will be discussing integration by parts. Integration by parts is just one of many methods to properly integrate a function. If you are unable to integrate normally, or if a method such as U substitution proves unsuccessful, you may be in need of integration by parts. If one side of your function can be integrated and the other differentiated, that is a good sign. The formula, in technical terms, is as follows. The integral of u dv equals uv minus the integral of v du. Again, I suggest you write this down. It is the integral of u dv equals uv minus the integral of v du. Now, we'll let Jack Metzen show you how this is done more precisely. To you.
That's why you got Mauer behind the dish.
You're right. So the first example we have right here, the function we have is ln of x over x to the fifth dx. And we're asked to integrate with regards to dx. So we notice that there are two main functions here. We have the ln of x and the x to the fifth. We know that we can't use u substitution because the derivative of ln of x does not cancel out with the x to the fifth. And contrarily, the x to the fifth does not cancel out with the ln of x. Also, we know that we cannot use the antiderivative, so we're going to have to be left with integration by parts. So for this example, the integral is the exact same thing as writing the integral of ln of x multiplied by x to the negative fifth. And this makes it easier when writing it out, so you don't have to deal with a denominator and a numerator, and everything's in the numerator. So when determining which one you're going to want to use for du and dv, you're going to want to use logpoet as a reference point for finding out which one you want to use to find the derivative. So ln of x is log, so we're going to use that one for u. We're going to set u equal to ln of x. So the derivative of ln of x is equal to 1 over x dx, which leaves us with x to the negative fifth. So we have dv is equal to x to the negative fifth. The integral of that is equal to x to the negative fourth over negative 4. So cleaning that up a little, it's going to be 1 over negative 1 over 4x to the fourth. So from that point, we know that the original formula for using integration by parts is uv minus integral of v times du. So from this point, we just plug and chug. We have u ln of x multiplied by negative 1 over 4x to the fourth minus, you have the integral of v, which is negative 1 over 4x to the fourth times du, which is right there. So we have 1 over x. So once we take this is equal to ln of x negative over 4x to the fourth minus negative 1 over 4x to the fifth. So we're going to take the integral of that, and we're going to be left with negative ln of x over 4x to the fourth minus 1 over 16x to the fourth. That is going to be your final integral.
And now, for just a second example to make sure that we have this solidified. Alright, so just like C4C Mattson, here's another integral. And just like he said, you start off with a log poet, but there's no logs in here. So the next thing would be p, which is a polynomial, and the simplest one would be the x. So x would be your u,
like that, which henceforth would be E would be the V1 x. And just like Kashaba said, the formula would be this integral of du, and we got to find the rest of them. So u is x, and we have to find v. So the integral of e to the negative 2x dx is negative e to the negative 2x over 2. So we have that, so we could plug those two in. So that would be negative x e to the negative 2x over 2 minus the integral of v du. So we still have to find these two. So the derivative of u would just be 1. It's an easy one. And we have to integrate v again. So we took it the first time, we should do the same thing over again. So the integral of negative e to the negative 2x over 2 would just be e to the negative 2x over 4. And now you just plug it in, you'll get your answer. So it'll be negative, you bring this down, you'll get negative x e to the negative 2x over 2 minus that right here, e to the negative 2x over 4 times 1, so it'll just be that, and that is your answer.
Thank you for watching. This is integration by parts.